Hey everyone, welcome to this explainer. Today, we're jumping straight into a high-stakes, microscopic battle. We are looking at the fight to secure our absolutely most vital resource, clean drinking water. Now, this is a battle that happens every single day, completely out of sight, and yet it is the absolute foundation of human public health and, really, our survival. So, let me ask you, is the water you're drinking actually safe? It's a pretty terrifying question when you stop to think about it. You see, water drawn straight from what looks like a pristine river or aquifer can appear perfectly clear, right? But it can still harbor these hidden dangers that are fully capable of triggering massive public health crises. We're talking about untreated water causing devastating, life-threatening diseases like cholera, typhoid, and dysentery. So ensuring safe water isn't just about avoiding a bad taste, it's literally about protecting society as a whole. All right, let's look at the agenda for today. We're going to cover 1. The hidden threats in water, 2. Physical and biological defenses, 3. Chemical and modern technologies, 4. City-scale to home solutions, and finally, number 5, emergencies and future innovations. Let's get right into it.
Starting off with Section 1, the hidden threats in water.
Interestingly, nature kind of groups our invisible enemies into 3 distinct threat levels. First up, we have physical impurities. These are the obvious ones: dust, sand, mud, the suspended particles that make water look cloudy. Then we have chemical impurities, and these are insidious because they are completely dissolved. This includes heavy metals like lead and arsenic, or agricultural runoff like fertilizers and pesticides. And third, biological impurities. These are the living organisms: E. coli bacteria, viruses, protozoa, basically the stuff that turns water into a direct vector for disease.
Moving right along to Section 2, physical and biological defenses.
Now, there's a really stark contrast between our simplest physical methods for dealing with these threats. Think about boiling versus basic filtration. Boiling your water to 100 degrees Celsius is incredibly effective at killing the biological bugs. The viruses and parasites are gone, but it leaves any toxic chemicals sitting right there in the pot. On the flip side, basic filtration traps the physical dirt, the sand and the silt, by passing water through a medium. But just like boiling, it lets those dangerous dissolved chemicals slip right through the cracks. Neither one does the whole job on its own. But beyond physical barriers, we can actually fight biology with biology. In processes like slow sand filtration and biofilm treatments, we literally recruit beneficial natural microbes. As the water passes through, these good microbes feast on and break down the harmful contaminants. It's an incredibly eco-friendly solution. Honestly, the only downside is that it takes a lot of patience. A traditional slow sand filter might process just a few liters per hour per square meter, making it a steady, natural marathon, not a sprint. All right, Section 3. Chemical and modern technologies. So before we even attempt to filter raw water on a massive scale, we often use a process called coagulation and flocculation. And this is just a fascinating chemical trick. We add chemicals like alum straight into the water. This forces those tiny, stubborn, suspended particles that would normally just slip right through a filter to magnetically clump together. They form these larger, heavy masses known as flocks. Once they clump up, they easily settle to the bottom and can be scooped right out. Now, when it comes to chemical disinfection, which is absolutely vital for killing anything that somehow survived the flocks in the filters, we have to weigh our options. Chlorination is the industry standard. It's widely used in treatment plants and highly effective at killing microbes, but it can definitely negatively affect the taste of your tap water. Compare that to ozonation. Ozonation uses ozone gas, and it's an extremely strong disinfectant that gets the job done while leaving absolutely zero harmful residue behind. Let's step it up to a modern marvel: reverse osmosis, or RO. This is where we bring in the heavy machinery. RO uses intense pressure to literally force water molecules through a semi-permeable membrane. It acts as the highly technical barrier that strips out almost everything. We're talking up to 99% of impurities successfully removed, including those tricky dissolved salts, heavy metals, and microbes. It's an amazing defense mechanism, though it is pretty energy intensive, and unfortunately, it does strip out beneficial minerals along the way. Alongside RO, we deploy a highly specialized modern arsenal tailored to specific threats. For biological threats, we use raw UV, or ultraviolet light, to zap and neutralize microorganisms entirely chemical-free. Ultrafiltration uses micropore membranes to catch any remaining bacteria. For chemical threats, nanofiltration targets those really stubborn, smaller pesticides and organics. Activated carbon is brought in to absorb impurities, chlorine, and bad odors to fix the taste. And we even deploy electric currents in a process called electrodialysis to strip out ions for desalination. It's an incredible toolkit.
Okay, section 4, city scale to home solutions. Let's see how this all connects.
Remember learning about coagulation, filtration, and chemical disinfection just a minute ago? Well, here is exactly where cities stack those precise methods in a linear, massive-scale operation. They start with the intake of raw water, then they guide it through coagulation and flocculation, let those heavy flocks sink during sedimentation, pass the clear water through massive filters, add that chemical disinfection to kill any remaining germs, and finally move it to storage and distribution securely right to your tap. Now, once that city-treated water hits your home, or hey, maybe you rely on an untreated private well, you might decide to deploy your own domestic defenses. And these can range from really low-tech solutions, like simply boiling a pot on the stove, using a cloth or a candle filter, all the way up to high-tech installations like a reverse osmosis or UV purifier tucked neatly right under your kitchen sink. Let's quickly synthesize how these methods actually stack up against specific threats. It's kind of like a game of rock, paper, scissors. Boiling? Great for microbes, but does nothing for particles or chemicals. Basic filtration catches the particles but misses the microbes and chemicals. UV only hits microbes. But advanced methods like RO and distillation, where water is boiled into vapor and condensed back down, hit all three threat categories: particles, microbes, and chemicals.
Finally, Section 5, Emergencies and Future Innovations.
What happens if you're ever stranded on a camping trip or facing a sudden natural disaster where the top water is totally compromised? Well, expert advice here is clear. Always combine your methods. Boiling is a fantastic primary defense, but if you can't boil, use a portable mechanical filter to remove the physical dirt and the parasites. And then, this is key, drop in a chlorine or iodine tablet. You have to give it the required time to act, but it will neutralize the invisible viruses that slip through. Stacking these methods absolutely guarantees your safety. Looking ahead, the future of clean water isn't just about raw effectiveness. It's about combining that science with true accessibility and sustainability. We're moving towards some brilliant innovations here. Think smart filtration systems, solar-powered purifiers that can operate completely off the grid, and advanced nanotechnology-based filters that can trap the absolute smallest chemical pollutants without needing the massive energy requirements of today's RO systems. We're looking at radically sustainable, eco-friendly systems. I'll leave you with this final thought to ponder. In a world with surging pollution and a rapidly growing population, how will we guarantee access to this fundamental necessity of life? Because mastering and evolving these principles of water purification isn't just some abstract exercise in scientific progress, it is the absolute non-negotiable key to human survival. How will we ensure tomorrow's innovations reach the people who need them the absolute most? Really think about that the next time you turn on the tap.